So in this lesson, we're going to be talking about making adjustments on a known range. So we must know the range. So if you've identified that the instrument needs adjusting at all, then or if you've got reason to suspect, so you've got a change of conditions, or it's your first time using the instrument, it's new to you, you need to know what value and you need to get it set up for you to use it. We need to do these adjustments. And you must know the range to within R squared. So as a quick test for you to use the tables that you've got in your notebooks, this is 1R squared. If the range is 1500, what's the R squared value? 2. So we must know our range to within 2 yards, basically. We must know that range very accurately for this to be able to be taken, because we're going to be adjusting the instrument based on that. So a known range might mean that you have it on a map. You are at a fixed point, a crossroads, an identifiable point on that map, and you're going to take the range on the corner of a house that's also marked on that map. You're going to know which corner it is. If we're adjusting within two yards at 1500 yards, those must be fixed objects that aren't likely to move. You must know exactly where you are on the crossroads, which side of the crossroads to be able to do that. Anything else would be like a rifle range, a small arms range. So if you know 400 yards, 800 yards, 1200 yards, the different firing points you're able to set up and do these adjustments on the known ranges. The range ideally should be between 2,000 and 3,000 yards, because the greater the range, the less error that is going to be imposed upon it. So it also gives you a region of between 4 yards right up until 9 yards. So you've got some distance to be able, some error that you can work in. You can work in that area. It should also be, I say a house, a corner of a house, something like that. It should be a clear straight line object on a clear straight line object on a skyline. Something that you can easily check quite well. Something you can see easily. If you have that known range, one of the methods to make sure that you to make sure the instrument's not too far gone, I suppose is the way of putting it, is set the range on the instrument first. So if you know that range is at 2,000 yards, use the working head, adjust it to 2,000 yards, then look at your target. Because that way you know how far out it is to start with. So you can adjust that. Then what we're going to do is take 10 ranges, everything's in 10. We can calculate the accuracy factor. So 10 ranges, mean observed range, work out whether it's less than 5, if it's less than 5R squared, we don't do anything. If it's more than 5R squared, we need to use the coincidence adjusting head, which, if you can remember on your instruments, is in this little window here, and will allow you to adjust the scale that's on the front here. Now, in this case, you can turn it left for minus or right for positive. One division on here is 20R squared. So this is why there's no point. One division, one sort of gap in the scale. One division is 20R squared. So 1/20th is 2R squared. So you can understand why there's no value in doing anything less than R squared, because you can't adjust it you can't do fine adjustment like this. So you'll check it. So for example, if the error is 16R squared, then this is 0.8 divisions plus, so we turn to the right, from the existing variation. So if there's already a variation on the instrument for some reason, or it's not necessarily a known if it's not an unknown instrument, you might have what existing variation is on here for your accuracy factor, or the instrument may come with a tag that says, it's already been tested. You can go and test it again. You can make the variation plus that. So if you've started from the variations, 2 divisions, you need to add everything onto that or minus it depending on what you've found as your accuracy. If you don't know it, make sure this is set at 0 before you start to do the test. So hopefully that makes sense. And that is something that you just cycle through. You keep doing those adjustments, take 10 ranges, do the mean observed range, work out the accuracy factor based on those, and start to do those adjustments through and through until you have an accurate instrument. You will need to make sure that you check the halving. So hopefully you can remember your lessons on that when you do so, to make sure the halving is accurate, because obviously that will affect what you're doing. And if there are a large adjustment, so if it's way off, then use an approximate setting first, perhaps. So if it's much, much greater, it's so far off, then perhaps try and set in 20 R², so 1 division at a time, to then take the adjustments to try and bracket down what you're doing. So if large adjustments, an approximate setting should be used first. Set the range scale to the known range, as we said, put that there, and then do 1 coincidence using the coincidence adjusting head. So you can actually, if you, rather than using the working head here, if you use the coincidence adjusting head to align it, that's your approximate setting. So when you get to the next stage and the practice, so the next session is to do practicing this lesson, and you've got 4 hours allotted to you to do that. Try setting it on an object that you don't know, and setting it using the coincidence adjusting head, not the working head, and you'll see how this also moves your coincidence alignment. Okay? Any questions? No. Then we'll move on to practicing this outside. We'll get our kit on and take some practices for this. Okay, excellent. Thank you for watching. Please remember to like and share the video and subscribe to the channel. Please support us on Patreon if you're able to, and let us know of anything you'd like to see in the future. I look forward to hearing from you.